Okay, welcome everyone at our weekly Cozystack community meeting. Here is our agenda. You can put your name into attendees list, and if there anybody new who didn't introduce yourself previously, that's a good time to do that right now. Do we have any members who want to tell about yourself? Please feel free to do this. Hey, I have to remember that we have Telegram group where you can join and ask your questions. Join also our Slack channel in Kubernetes official Slack. And let's switch to agenda. And the new release was released with a hotfix. There were a few changes. RabbitMQ get the configuration for users and virtual hosts. We also updated some applications like MariaDB operator, and also syntax for MySQL has been changed. Now it is pretty similar to what Postgres had. And also, we added password generation for Postgres and for ClickHouse applications. So for now, we have almost every application which requires a password. It can be automatically generated. The next release was 14.1. There were also a few fixes for previous changes. Not much, but we are working. And I want to discuss a few topics. There are a few topics which we didn't discuss previously. But let's start from the beginning. For now, we can start from opencost and costs management in Cozystack. So we are going to implement opencost. In current implementation, it allows you to count CPU usage, memory, and persistent volumes per namespace. I think that should be enough for the beginning. It would be nice to add network utilization costs, but so far I know that there is only one implementation. It is in KubeCost project, which is not open sourced yet. Maybe someone know the other solutions, maybe alternatives for calculating the resource usage per month and per day usage, or do you have any thoughts about that? Georg, please.
Hi, regarding network, I have no ideas just to make our own solution, but what I really worry about, so it's the purpose of opencost. So I may guess that we want to provide the users of Cozystack a reliable data about resource consumption. But how reliable this data could be? What I mean, so if somebody will rely on this to provide financial reports regarding how many money like Quaps tenant owns to the owner of cluster or test user to owner of cluster, it could be a disaster in case of corruption of this data, or just if these data are inaccurate.
This is a good point. I think it can be we can consider which solutions are reliable and which are not. The opencost metrics are based on standard Kubernetes metrics, which are taken from Prometheus, and in our case, Victoria metric storage. So it consists of few components. It is reading the data from the database which Kubernetes sent, and then also provides its own calculations for persistent volumes and things like that. I'm not sure if there is more reliable mechanism for this, or how can we make it more reliable, or what is your main concern of using this tool?
My main concern is that, let's say, for some reason, some Kubernetes node was inaccessible, yeah, but the workloads were running on them. It's just a corner case. There will be a lot of corner cases which we can discuss. So let's try from the simplest one. The workloads were running. These workloads were like assigned to some tenant or user. Yeah. Would opencost see them and count them in the final report or no? Or second thing, what will happen if Prometheus or Victoria metrics would be inaccessible by opencost or would be unavailable at all? Third question, how reliable could be the data from Victoria metrics itself? Because if we have a shared CPU, the calculation of CPU time could be just inaccurate because of physics, how it just works. So it's why in enterprise, I would try to split the tenants not by pods itself and use a shared CPU, but rather use a dedicated nodes, and the billing would be much easier. So I have a bunch of questions, and unfortunately, there are no like obvious answers to them.
Sorry, I will write it slowly. So what are concerns? So the data can be not reliable. The nodes can be inaccessible.
Unavailable by Kubernetes, but workloads are still running. Not also reliable, but accurate, because accurate is very important thing when you are talking about finances. So I totally sure that if we will have a customers and they will get like inaccurate data about resource consumption, they will be not sad but angry, because if they will pay more than they consumed, it's a disaster. If they pay less than they consume, it's a problem for us and problem for users of owners of Cozystack installation, because they are losing money. They are billing users less than resources were consumed.
Can't those cases be covered by adding median for resource consumption?
Median won't help, I think.
Like what was before at the time of outage and what was after the, I know something to, there were some option in Grafana that they can join, it can join the points if their data missing. I think it can use some mechanisms like that.
It's
And
not about Grafana at all. So also arises a question how reliable all this consumption data is stored. So I bet that it should be stored in something like Postgres, not like a time series row in Victoria matrix, but in some transactional storage. And we should have some snapshots of this data, so we could check that they are not corrupted during ingestion.
but I don't think that time series DB can be somehow corrupted.
Victoria metrics corrupted? I think it could be easily done.
Okay, I just have no such cases.
Yes, so there is a difference between types of databases. So if we would store this data in ClickHouse, I would bet that we have no warranty that it could not be changed after we ingested it there. Just, I don't know, like some broken hard drive or something similar. Transactional databases should give probably more warranties, but I'm not a very big expert in this field. So again, I have a very big concerns regarding accuracy and reliability of data which we will get from opencost.
That's interesting. If there are any other solutions for cost calculations, or if anybody knows how is it done in different systems. I have only one experience, is OpenNebula, and they have their own metrics exporter, and they're storing all the data in XML format in MySQL database. To me, it looks like a very...
Well, I want to keep your attention that it's MySQL. It's not like a Victoria Matrix or any other solution.
Well, but they use MySQL as key-value database. You know, they're storing XML in MySQL rows. That looks so weird.
Weird, but it's reliable at least.
I wouldn't say so. I don't know. Maybe Robert can say something.
I can share our experience. So when we build billing, we write exporter, another exporter, which was there was only one purpose. It pinged all virtual machines and set a flag into database 0 or 1. It means 0 if virtual machine is down and 1 if virtual machine is running. And then you can make a specific SQL request, and understand how many periods in time the virtual machine was running. Yes, it's not very precise thing, but at least you can say that in this interval of time, probably virtual machine was a whole interval inaccessible. So we don't need to be the owner of it. If virtual machine is deleted, so the matrix becomes 0, of course, obviously.
Okay, I think why can't we implement the same mechanism in Kubernetes and store the data in time series DB, but also calculate where ping check was okay?
Because we also had another source of information, which was so what's the issue? Virtual machine could have a different flavors, different size. So you can change the size from 1 CPU to 2 CPU or vice versa, right? And this process should be done with shutdown of virtual machine. So you have an audit log of all operations with the precise timestamps on the control machine, control server, and you can restore all the operations in time and understand from yesterday till now minus 1 hour, the virtual machine has such a configuration with a such price. And after that, it has another. So you can double check the data from different sources. In case of Kubernetes, because of ephemeral nature of pods, you can do it. So it would be much complex task. So I agree that the naive approach is to rely on monitoring, like on global monitoring of cluster, like Prometheus, Victoria Matrix, and yara. But how proper data we will get from it?
This is a good question. I don't know. I have no experience with that. I might ask the community if somebody use opencost or some methodics for calculating costs for charging their customers. Does anybody have experience here?
Yes, I have some experience with that. I'm not sure if I worked with opencost, but there was a solution which allowed to make some cost estimates. And under the hood, it just had a couple of coefficients, and it just multiplied CPU and memory usage from monitoring. It just multiplied on these coefficients. And for example, then it got the AWS instance cost, and as a result, it came with some number.
I want to highlight two very important things. First of all, it looks like that you don't have a necessity to provide a precise financial data. So it was like your internal relations between different departments, and you need just to understand the power of number. Like we are spending like $10, $100, or I don't know, like billions. Yeah. So it's not about precision. The second thing, if you had an exporter from Amazon, yeah, we already thinking that Amazon exporter is giving a precise numbers because it's underlying cloud, it has its own billing, and it should be precise.
Yeah, from billing perspective of view, for example, if we provide a commercial service which runs spots, I think relying on the monitoring will not be suitable.
What the solutions can we use? So we can write a service, for example, in Go, which will go and calculate all the metrics at the specific point in time and write it into database. But it looks like totally similar what Prometheus and all its experts do. Why can't we just use the data for calculation, the billing data? Okay, it may be not very accurate, but we can prepare specific logic. Still, if you say that you have ping check for your virtual machines, this is pretty similar to having no the data from the specific time.
I can explain what is the difference. So basically, if you are using Prometheus, it means that you have a very large scrape interval for billing purposes. It could be like 10 seconds or 20 seconds. Probably it's too much. It's a question of discussion. So, okay. But if you will write an agent which will be running on the node itself, it means that you can have as good precision, so small interval of time, yeah, like 1 second or even less, and store this data locally, and synchronize it on demand with a central part of the billing system. So in case of node outage, you will get the data when the node becomes available. If we lose the node at all, yes, we lost the data, but in case of Prometheus, we also will lose it. So we only gain and not lose.
We can add the additional exporter, which will do check if the service really up, even if its node is not up, by the same sending ping checks and make the calculations according to the output of this exporter.
Andrei, it's not about service up or is not up. It's about storing the precise data and synchronizing it with a central part of billing.
Yeah, I would add that Prometheus is not about guarantees. It's about giving you estimates or something. Regarding cost allocation or cost management, not management, how to say that. So I would suggest that we just enable Kubernetes audit log and parse the creation of resources. For example, pods. Audit log allows us to make precise timestamps and to check the states of pods or whatever running. So it seems to me like it's a good solution. So we just stream audit events to some storage. Maybe it could be like Kafka or something. And based on that, we can get labels from pods or whatever metadata we want. And we could be able to generate exact time time points.
The only
time
issue,
points and
Nikita,
all
sorry,
these things.
sorry for interrupting you. Audit log or events log, they both are the same. So let's don't distinguish between them. But what is important point? It is a good thing, but it would not give you a precise estimate how much resources your pod allocate in fact. So what I mean, so if you are creating pod with some limits on memory and CPU, it's a good data for billing purposes because it's a cap. So let's say if we have limit CPU 2, we should not bill more than 2 CPU. We are just thinking that pod could not run more CPU than it was allocated. It could, in fact, it could, but we don't care. Yeah, okay. But if you want to make a like fair billing and pay-as-you-go model, then you need to get a precise number of CPU allocation for this pod. So not 2 as limit, but like 1.5, 1.2. So how much CPU was in fact used by this pod, and it's much more complex task. So I prefer to switch to the first approach and not to calculate the actual resource consumption. It also made in the major publics when you are ordering a virtual machine with like, I don't know, several CPUs, several gigs of RAM, and you are paying for the whole amount and nobody cares how you used it in fact inside of virtual machine.
I agree with that. Billing for actual usage is a much more complicated task, for sure.
Well, we have few sponsored requests for this feature, and one of the client who want to have it, they suggested using kubecost or opencost. I think we can try to implement it as it is right now and check if it provides needed information for them. At least for now, I don't know any other solutions for cost management which would work different way for Kubernetes. So let's keep it as is. Thanks for this discussion, and let's switch to the next one. The next discussion is public tenant API proxy. That means that we never considered existing Kubernetes Cozystack API as public API, but some service providers still want to give this API and access to the dashboard to the end users, and we need to find a solution for making this API interface available to them. And there are a few options how it can be implemented. I think the best one is using Kube API proxy, which would allow to spawn separate Kubernetes API server per tenant, and also do the translation of APIs into existing Kubernetes cluster. This would allow to specify separate settings for OEDC per every tenant, but also represent the existing resources, like we have Helm releases right now, Flux Helm releases. They can be shown as separate resources, Kubernetes resources, in this custom API server. What do you think?
Sorry, I not got the idea. Probably, could you please make some RFC or I don't know, some specification, or draw the diagram how it should look like?
Yeah, let's go to drawing. For example, we have Kubernetes API. Our management cluster. We have control plane. One common for every tenant. And we can also, when we create new tenant, we can create also a separate microservice. This is our API server, which will run its own API server. But this API server will work as proxy to this API server. So we can filter all the requests. So this API server can be given to the tenant itself, so they can communicate with it publicly. And we can filter all the requests which we don't like and make our own representation of the resources.
I don't get the idea. So you want to make a proxy which is pointing to the API server of management cluster, right?
Yeah. And for example,
why we need to do it? Why we could not just publish API server of management cluster directly? It already has all our bug features, and so it's secure enough, I think.
Because right now there are some applications, and we don't want to let users manage specific parameters like domain name and I don't know, to make some services external or not. This feature can be given through the values files, but we don't want to let it to do to everyone to use those features. So the main idea is to translate. Okay, let's try docs. So for example, if we have this Helm release, which is deploying monitoring chart with this set of values. Sorry for idents, they're wrong here. But my idea is that we can transparently transcode this resource to this one. So we will have two API servers, one for tenant, which will have this kind of resource, but it will be translated to this resource in the upper API server.
Yes, but look, so I agree with additional API server, but it should not be an API server itself, but what is called API server extension in terms of Kubernetes, which is serving additional type of resources. But why it should be placed into tenant cluster? It should be an add-on to the main API cluster. So again, if you are solving the task of publishing the main management cluster API to tenants, it could be just done with the publishing of API servers externally. I don't understand, still don't understand why we need additional proxy to achieve it.
I think because we want to cover some Flux options. First, the resources like this can be more understandable because they are normal API resources. Of course, we can create custom resources and let users manage just this. But I think it would be really nice to generate, to provide a functionality to generate them on the fly. The main idea that this custom API server, it can be run this configuration, which deliver it specifically for every tenant. For example, one tenant can be see some parameters, and the other tenants can be see the same resources with the different parameters.
We need a proper description of user case, I think, because it's very hard. Again, very hard to justify why we need it.
Yeah, Robert, please.
Maybe to George ideas, it will be not solve the problem, the provider service and the load balance traffic to this API server on the tenant.
Not sure. I probably didn't get this comment.
If we will just provide this Kubernetes service, and we will be route the traffic on the load balancer to this service, and then this service will be a connection with the API server for tenant.
Yeah, got it. There is no issue for publishing existing Kubernetes API server externally. The only thing I have a fear that it is not very secure. And one more thing that sometimes we still need the opportunity to specify custom OEDC providers for every tenant. And I think it would be really nice to create such thing as BFF, backend for frontend, which can also be used as backend for the new dashboard, which will use these resources to manage Helm releases. So I don't know. This is a very interesting topic. But do you think?
To be honest, I just dreamed today that we will have custom resources like Cozystack, Ænix, IO, yeah, for monitoring, managed Postgres server, MySQL, and other. And we will be able, in such a way, abstract, in fact, a particular service and change the backend on the fly. So if we decided to move like from FerretDB to a native Mongo, the resource will be, the Cozystack Ænix IO resource would be the same, like document DB or something similar. And the backend will be changed on the fly.
This is one of way we can go, but we still position Cozystack as a framework. So it is intended that you can add your own custom applications, and not everyone will understand how to create their own custom resources and create controllers for them. So I think the way when we just transcode some configuration into custom resources on the fly, it might work really good for extending this platform with custom features.
So I'm voting for custom resources, like you described below, but still I don't see a connection with front end and even with tenants clusters.
Yeah, I'm not talking about tenant clusters. I say only that when you create tenants in Cozystack, you can get your own custom API server, which will represent all the resources in this format, dynamically generating them. So upper Kubernetes cluster operating with Helm releases, and it is managed by Flux, as usual, the same thing like we're having it right now. And this proxy, which automatically transcoded to this format according to the configuration provided to this proxy API server.
Would this translation one way or two way? So user could change these parameters and they will be reflected in the main cluster.
Yeah, sure. They should be also status you're seeing here. It can be collected dynamically from specific resources like ingress and services. The same way like we're doing configuration for the dashboard right now.
I think it could be achieved without writing another controller. Yeah, because we already know that all tenants clusters are available to the management cluster. So if you put some kind of controller which will synchronize an object you wrote on the top of your page, Helm release, to an object on the bottom part of your page in tenant cluster, it would be enough. So you don't need to have a specific Kube API proxy.
I really like this idea that we can create a custom Kubernetes API server with its own storage. So it will be stored in etcd and use it, and custom controller, which will allow to perform the logic specified here. Yeah, thank you. I think even tenant Kubernetes clusters can be used for storing this kind of information. The only worry is what should be done if you're removing this cluster without removing resources from it.
Nothing. Because
they will not be removed.
Because what I really care about, so let's say you have tenant inside of another tenant, yeah? And you want to have a monitoring object in all tenant clusters, yeah? 3 tenant clusters, you can imagine. But in fact, they should not be changed inside of tenant clusters, because otherwise they could broke a management cluster. So all changes should come only from one point, from management cluster and admin panel.
Yeah, but what if we want to provide the functionality for ordering services using Kubernetes API?
No idea. Please provide the use cases and we will be able to discuss it in more productive way than right now.
Okay, I will collect use cases and we can try to discuss it next time.
Because right now it looks like a very interesting idea, but like another technical challenge just to implement it. And what's like business impact?
As
Yeah.
we have to publish. We have to provide a way for publishing our API to the end users.
I think
Without
there is no
making
issue.
impact.
Look, I think there is no issue with publishing a management cluster API. We have Verbug, it's enough. If you have some like considerations about it, if you will publish a tenant API cluster and you will put there some flags or some options which could change some objects on the level of management cluster, it could create another weaknesses, vulnerabilities.
The way I like to do with proxy, because you can implement all the checks on the proxy side. The configuration for those checks can be done on the fly. For example, there is...
Yes, but the question is, so if this proxy has some access to the main Kubernetes cluster
Yes,
or not? It has.
Yeah.
Bad. It's bad, because if it has, it means that if somebody can hack this code or put there some data with, I don't know, like, some SQL injection or something similar in terms of HTTP protocol, we will get troubles.
The same way, if we just publish management Kubernetes cluster API, there are always possible impact on it. At least someone could try to DDoS it or...
No, I think, okay, so regarding DDoS, I agree with you, but it could be eliminated very easily. So you are just putting some, like, I don't know, Nginx behind management Kubernetes API proxy and implement a strict rate limiting on it. That's all. No DDoS.
That makes sense. But still, how can we achieve automatic configuration for OEDC per tenant?
I have an idea. So my idea is the next. We can leverage some OIDC provider inside of Cozystack. It would be a global OIDC provider to the management cluster and to all tenant clusters. It could be Keycloak, Citadel. I prefer Citadel, but okay, let's choose it later. And then we can set up all Kubernetes cluster to this OIDC server. This OIDC server could get users from different sources like GitHub, Gmail, even in the same time. We are setting up groups inside of OIDC provider, yeah, and it will give to every tenant its own group, and we are done.
That sounds interesting. I thought about the similar approach. The second thing I don't like is to representing Helm releases resources as is. So there is still needed some translation, I know, custom controller and custom resources for this. And it would be really nice to have the opportunity to generate them dynamically. For example, if you use KubeApps API, you will see that every Helm release, I know it implements its own API, but it would be nice to keep compatibility with Kubernetes API. So I don't know, maybe it is still an option for making dynamic API client or server. I will try to play with this and then share my thoughts about this. Anyway, thank you.
I also want to add that I like the idea of custom resources because it gives us more control over parameters which are passed to these custom resources. It does not matter, is it a API server extension or just a custom resource, but in comparison to Helm release, we have more options to control the flags.
The same way as with API proxy, API server proxy, we can have more control for every request is done, and we can specify custom configuration for controlling this creation. So every user of Cozystack, every administrator, they can provide their own configuration, which applications should be published, and which parameters for those applications can be managed using some standard configuration language. Okay. The next topic is backup policies feature. This is about adding more backup backends for support. We got requests for supporting Proxmox backup server, and I think there might be more options like for simple REST server for RESTIC and other type of storages, S3, NFS, custom PV, I know, and things like that. So do we want to support other backends, and which backends should be supported? For now, we have S3 support. Either any other backends you want to use? This is a question for the community. For example, NFS, I don't know. I would put REST server. Personally, I really like it.
It's a RESTIC server, right?
Yeah. And we got the request for Proxmox backup server. Not sure. Does anybody have experience with it? Not sure which protocol it uses.
What is it?
Proxmox have on the hood NFS connections for backup server.
Don't you know? Thank you, Marian. Don't you know any format it used for storing backups? I guess it is just pure files with metadata.
Yes, but it needs to check in documentation of Proxmox server more precisely.
Thank you. So, and the second feature I wanted to talk about is backup policies. So for now, when you want to establish backup policy, you have to specify it for every specific application, like Postgres, MySQL. For every deployed instance, you have to specify separate backup settings. So I think it might be really useful to create one common configuration, like backup policy, which will backup all the applications or type of applications it requires. Any thoughts about this? Or it is fine as we have it right now? No idea. Okay. Let's switch to the next topic. Use capsule for tenant management in Cozystack. Does anybody have experience in using capsule from Classics? It looks like it implements the same approach we have, but use custom controller for this. So it implements additional custom resource for tenant, and it is allowed to assign users and groups to these tenants. Pretty similar design with what we want to achieve. And I just asking for the feedback if anybody used this. How is it applicable for our current Cozystack design?
It's an interesting question because I tried to use Classics, but it wasn't very successful experience. It was a long time ago. Probably they made some changes. But what you really want? Do you want to just take their like specification and re-implement them, or you want to take a Classics operator and use it in Cozystack?
I think both options are under the consideration. If we can just take and use it, this is always good because we will have the same code base and we can rely on this solution because it is CNCF project. And I guess many people also using it. So it is always better to keep the standard in specification, which is in use by other projects, rather than implementing our own. But in case if it will be really difficult to change our approach to this solution, we can, of course, we can implement our own tenant model and write our own operator for this based on the functionality and seeing how capsule actually works.
To be honest, I thought that capsule is a thing that splits one Kubernetes cluster into multiple ones. So it's not like our approach when we are creating additional Kubernetes clusters, but rather isolating Kubernetes API in such a way that you see only subset of, like, let's say, namespaces in main cluster.
Yeah, but if we will implement users and groups which can be authenticated to the through the OEDC, we would really like to assign, to have to provide them opportunity to assign those users and groups to specific tenants of the Cozystack. And I think this is exactly the same approach we're having right here.
Yes, but there is a like drawback, because if we want to support a multiple OIDC sources, it means that Classic solution would not apply for us. So let's say we have like 10 tenants. Yeah, these 10 tenants has its own API inside of cluster, and they all want to have its own OIDC. In case of central OIDC, we can somehow properly map the groups, and we are done. But in case of Classics, I bet that we need to have a single OIDC and import all users. So we don't have any advantage.
No, I think it should work. This is same about kubectl. Yeah. So it should work the same way if we're using single API server, because I guess all these tokens will be just transcoded to the upper API server. Not sure if they use their own API server. I guess they provide just abstractions like custom resources and controllers for managing it. Maybe I'm wrong. I never tried it yet.
So we need to understand what does it. Yes. So what is written? So capsule. So yes, what I told you, capsule is splitting one cluster, yeah, into like several clusters, but in fact it is the same cluster. It's a different approach than we use.
Yeah, I'm not talking to provide those virtual clusters to the users to have the opportunity to run their workload. But I'm telling more about providing resources once and recursively for all the namespaces created under this tenant, and also for configuring users and groups to tenant assignment.
I think we should avoid classics, build our own OIDC, put the all groups. So if you are stating that, so what's the issue with classics? Yeah, that there is no recursive tenant.
There is.
Where?
They have tenant, which is actually tenant, and inside of this tenant, you can create namespaces, and they will be created recursively in this tenant. Yeah, I get your point.
Yes, but it's not recursive tenants. It's a namespaces belonging to one tenant.
Yeah.
So it would create a mess because it's very difficult to explain, but I see again a lot of corner cases as a namespace should be marked somehow that it's belonging to one tenant, probably labels or annotations, but sounds terrible. I don't think that Classix is a bad solution, capsule, yeah, but it's a very niche one, and we should very well estimate how proper is the idea to bring it to Cozystack. So again, I want to return. So if you are stating that all tenants has its own unique name, it's not an issue to bring any OIDC provider into Cozystack and programmatically create a proper group with unique names inside of this OIDC and pin them to a management cluster and to tenant clusters as well.
Correct. Well, thank you. I think we can. We have 6 minutes left, and we have also the last topic is external packages and using Cozystack as framework. Previously, we already discussed developing the common tool for creating your own Cozystack. This question is more likely about creating to provide the opportunity for adding user repositories like Arch Linux Our. So we can create some separate repository for community-based packages and allow to connect them to the Cozystack. What do you think about this?
It's a nice idea. And how we help to implement this?
I think it should be Git repository. It should be fully managed by Git, and it should be possible to connect it to Cozystack with a single resource like Helm repository. So it will discover and make these packages available for everyone.
Okay, nice.
No idea, because from my perspective, it should be just a flag like external Git repo, yeah, where probably templates for Helm releases could be provided. I'm not sure about format, but it could be just done in Talos or in some Helm charts, flag extra manifests.
Yeah. This might be working just by adding this configuration and the initial Cozystack setup. So first time when you apply Cozystack installer, you can also apply custom Helm repos. So all the packages will be download it and be by Flux source controller and will be shown in dashboard. I think it should be really cool to have this community repository. The good question, what should be stored there? Some community packages. Why to keep them there instead of having them
Look,
out
so,
of tree?
so we should agree on the purpose of this repo. What we found that we want to give our customers some opportunity to extend Cozystack with additional applications, but we don't want, for different reasons, to put these applications into the core. If we would put them into community repo, we will have the same issues as we had with the Cozystack repo itself. Like, I don't know, like licensing or some export controls or something similar. So probably the best way to give the option for users to extend Cozystack is to just give them a plain key, like external manifests, yeah, where they can put any arbitrary manifest, including a template which will install additional application into kubeapps. And we can describe the format of this, like, let's say, repo, yeah, if it would be a Git repo, how it should look like to make such an extension.
I think it should be even better to provide a tool like Kube Builder or Operator SDK, which will generate the structure for you.
No, anyway, we should start from the repo template, and then it could be consumed by this tool. It could be just a cookie cutter, for instance, a typical tool for creating a new repos from a template repo.
That makes sense. Okay, we have 1 minute left. And I think
one more thing.
Yep.
Yeah, sorry for breaking in. I think we should add here that we should think through how it could be specified in bundles. So how do we specify external packages in bundles?
I thought about even moving bundles to have every bundle to keep every bundle as in separate repository. So this is in future plan to move the main configuration, the main bundles configuration, to develop them out of tree. But for now, what we have, it's a single configuration which is maintained easily in tree. I think if we will have more contributors, we will definitely put it out of tree. And in this way, every custom package can be connected as additional bundle. So, okay, thank you for your input. And also short announce, the next week there will not be meeting. We will move it to be in week later. So see you same time in 2 weeks. Thank you. Thank you for attending. See you.
Bye.
Thank you. Bye-bye.
Bye.
Bye-bye.